We are going to dive into detailed design today. And this is going to be a little bit ahead of schedule of what you're working on in your projects. But things are really going to start to get more and more project specific as we go. So we're going to kind of give you an overview of what we're essentially looking for as you get closer to the end. All right? And then you'll be able to ask a lot of specific questions about yours, because everybody's going to have slightly different stuff, I feel like. We've got a lot of questions in the last class about, well, what does this mean for my project, okay? So we're going to give you the broad overview now, and I do expect and feel free to ask lots of questions, and we'll have time at the end of the day today for you to work on things and for you to ask questions we'll go around to different groups. I also have, we have all been able to give you another work day next week. So all three of us are going to be here for all the different sections, all the professors, and we'll have basically meetings with all of you that will give you another opportunity to ask questions. So if you don't have them today, you have a week to basically kind of think about them, and we'll be at your disposal to help you work through the design process as it pertains to your projects and asking specific questions. All right, so today we'll talk about some of the future stuff that you'll be doing as part of prototyping, testing, analyzing, and iterate. We're really in a big portion of the iterate part of the design project. And I'm going to go through each of the different design processes and tell you where we're at. So whichever picture you're resonating with and following, you can match up where we are. We did project identification, specification development. We talked about conceptual designs, which is what you're really focusing on this week. And today we'll talk about detailed design. So we're getting close to this delivery endpoint there. So we're giving you a taste of what you're working for. If this is the design process that resonates with you, we've done these four: define, identify, brainstorm, and select. We've talked about those. You're really working on this brainstorm and select portion, the conceptual design portion. And today we're going to talk about prototyping, testing, and I'm going to mention why iteration is important and how we're really working on iterating. If you look at the last process, there's iteration arrows all over the place within all these, going forwards and backwards, okay? So iterating is really, especially now, happening all the time, right? Not as much in the beginning, but more so now that we get further. You may have to go back and refine some specifications. Maybe as you're doing your detailed design, you have to go back and generate new ideas because something didn't work. So iteration is going to be all throughout now. And then lastly, if the acronym DIP and PIC is helping you remember all the steps of the design phase, we did define and ideate. And I am throwing in a plan here. So I'm going to talk about that a little bit. I think this is an important time to rework. There was some pre-planning done for you when we, as professors, came up with a schedule of kind of what you should be working on each week. It's very general and high level. And as we get into this detailed design part, once you have an idea that you're moving forward with, that is the best time to go through and really look at what your plan was, all right? And see if there's risks and get your Gantt chart updated with a lot more details. Today we'll focus mostly, though, on talking about the prototype of the design phase. And of course, iterate is happening all throughout these because you're going to get more and more detailed as we go. So we're going to do different levels of prototypes, and then you'll go back and sort of refine your ideas and move forward. So iteration is now going to be happening all the time. So today we're really going to talk about design, analysis, and evaluation of your project, or maybe you've broken your project up into different sub-functions or sub-modules. We're going to talk about DFMEA later, so we'll get to that a little later. We'll talk a little bit about prototyping and then field testing of your prototypes. All right, so these are things that you'll be doing in the future once you come up with your idea. So I've got an idea. We're moving forward. Now what, right? We're going to work on getting a prototype that meets our specifications. So important to have your specifications your problem identified, okay? Because if you don't have that, you won't know if you've made a successful design. All right, so keep refining those problem statements and the specifications. We will be having a presentation after the spring break when you come back that will talk about problem identification all the way through conceptual design process, so the ideate portion. And at that point, you really are going to have your specifications and problem really nailed down. So really continue to work on that, especially as you're working on your report right now. Try to get those hammered out the best that you can, and we'll be able to give you some more feedback to help you get sort of to some really nice specifications, because that will make all the difference when you're trying to come up with solutions and see if your solutions are going to be good ones that you can move forward with. So once you have an idea, I think it's really important to go back and think about your plan, because your plan didn't know at all what your solution is going to look like. And now once you have that, make sure that, well, first of all, you have your problem statement and your specifications really well nailed down. Probably update your project charter, because that has your description of your project in there. You may need to change that up a little bit. Maybe your scope of your project changed a little and you have a little bit bigger or smaller scope, something like that. And then update your Gantt chart. You'll be able to put in more and more details now that you know what your solution is going to be. Especially if you've done functional decomposition, you can break up your project solution and what you need to do into different parts and start assigning people to those things so that each week you're all working on different things and trying to accomplish them. It's really hard to make a very detailed Gantt chart before you know what your solution is going to look like, right? You don't know if you're going to be building something or just designing a process or what really is going to go into that solution. So now you can put in some of those details. So this is part of the iterate part of your process as well. You're going to update some of your stuff. Now, my big question for you is, are you meeting weekly face to face? Some yeses, some no response. It's a must, all right? We have heard through the grapevine that there's some issues arising in groups, to be expected. And if you're not meeting weekly, most likely those issues are arising in your group, all right? Communication is going to be a lot easier if there's a set time every week that you meet, all right? There's an expectation. It's a way for everybody to check in, see how everyone's doing, and hold people accountable, right? So meet weekly. Take notes at the meeting. Make sure you assign people to do stuff so that there's an expectation that people are doing things for the next time you meet. And then you can hold them accountable if they understand what they're doing for the next week and see what's happening, like, oh, you know, why didn't we get this done? Or maybe they did a great job and maybe they overachieved, and you can give them a pat on the back. All right? And then don't forget about documenting in your design notebook. So as you're doing stuff outside of these weekly meetings that pertain to the design process, put them in there, all right? Every day, think about that. It'll make your lives that much easier. All right, so that's the plan. I think it's important to really flesh out your plan again, kind of take stock of where you're at, and then where are we going with this? We're going to prototype, so build, make something, right? And we're going to want to test it and analyze it. We're going to want to see, hey, did we build and make the solution we expected to make, all right? And so here is where we're going to iterate and get into finer details, maybe fix things that aren't working throughout this part of the design process. So what is the end goal then of this part of the design process? So we're going to get into finer and finer details as we go. We've been more high level, thinking of ideas. So essentially, either for your whole project or separate functions, you're going to look at what you've designed and try to analyze it and evaluate it. All right? And you can do this by doing some prototyping. You can do this by doing testing, thinking about what are your specifications, and did we meet them? All right? What are our user needs, and did we meet them? It's going to be iterative because the first time you do it, it's probably not going to work exactly as you expected or as well as you expected, or maybe not at all, right? So you'll build again, you'll test again, and you'll go and iterate. All right, all of these things that you're going to keep doing successively a few times are going to lead to some design outputs that will support manufacturing and using your final design. We're going to go through each of these in a little detail, but you're going to want to have prints or schematics for your design or process, a manufacturing, routing, or productions plan, a bill of materials, a manual, and do some testing and get some results. All right, so these are the end goals of the detailed part of the design process. And this is a lot of stuff that leads to some of what deliverables you have at the end of the product process when you do your final delivery. So that's what we're working towards in the detailed design process. So what are all of these different things? Print schematics, here's where you can do some 3D modeling in SolidWorks, create drawings, maybe you have flow charts to help go through the process of what you're doing. I don't think anyone for these particular projects, oh, there might actually be one group, the voice controlled bed, they might have some electronic schematics that they're working on. All right, so different sorts of pictures that sort of say what you've done, what you've created, right? Next, what is a production plan? So here is where you really tell us how are you going to make what your final product is going to be, all right? And this comes from your manufacturing class. And I know at least in this section of the class we have a lot of people in the management. So hopefully there's another person on your team who has taken manufacturing if you need to like build something. Or this production plan could be more of one group we have doing a database. And so the production plan is more how could you replicate making this sort of end product elsewhere, right? How could you duplicate it? How could you get it again? So that's what, like when you build something, the production plan is describing how do you make your final product, is essentially what it's doing. All right, so if you are actually building something, you would number your steps. You would have a description of what it is, talk about what part it is that you're dealing with, talk about what machine you're using or a tool you're using, one of them, and talk about what process parameters you have. So if you're drilling a hole, what size is it and what speed does your drill run at, okay? And then you have a column for references, so if there's, especially if there's special processes that you're doing, you have a reference for where you came up with some of these speeds for your drill, for example. All right, so this is from manufacturing, and it may be slightly adjusted if your project does not have you actually build like a physical item, but has more of a process to it. All right, so you may not quite have a machine, but you may have a tool. Maybe you need a camera or ruler or something like that. All right, so if you have questions about your specific project, we'll have time later today and on Tuesday. As you're thinking about how you're going to get this end product, though, you really want to think about how you can minimize cost and time. All right, so there's a bunch of different things that we can think about to do this. And I just kind of want to highlight some of these bolded ones. Simplify. How can we make things simple, right? Simple to use, simple to make. That's a key goal. Using common parts and materials. That's going to make everything easier and simpler if you can buy off-the-shelf products to make your product as opposed to having something specialized. Think about making a mistake-proof product or design. So how might it fail, right? How might a user make it fail? That is actually DFMEA, and we'll talk about that a little bit later, but something to consider. Then you could think about things like ease of assembly or trying to make things modular. Like how could we maybe, if our end product is something we actually build, could we manufacture it in 3 different maybe plants and then put it together at the end and assemble it? So I have an example here for you of what this overarching sort of theme is really make it simpler, right? So look at the product we have on the left. Look at all these different parts. Look at all the different things we have to put together. All sorts of nuts and bolts and screws, and there's a lot of moving pieces. More likely that you're going to make a mistake. Alignment may be an issue. A lot of things could crop up with this design. But what if we rethought about how we put all this together? Instead of having separate pieces that we put together, what if we just had one big, say, metal sheet that we bent instead of having two sides, right? See how much simpler that is, right? So yes, we have to bend it now, but we don't have to put in all these screws. We don't have to worry about alignment. Now, we just have to put in our handle. All right, so think about these things. This is part of the detailed design. Once you have your idea, maybe you built something, now you can think about how could I make that a little bit better, a little bit simpler? How could I minimize things, right? How can I make it easier for somebody to assemble or use? So that's what we're really going to be focusing on in this detailed design part. You also are going to have a bill of materials so that people need to know what they need in order to make your final product. This is also from manufacturing. All right, and so you're going to number all of your materials, say how much you need, describe what it is, what it's used for, and what dimensions it's in. All right, so that's another thing that you're going to want to have. And then lastly, you're going to want to do some testing. All right? So what is testing? It is like a wide gambit of so many things, right? It can be measuring things, it can be doing analysis, whether that's hand calculations or using MATLAB to do computational things, or maybe it's SOLIDWORKS modeling and then doing some tests within SOLIDWORKS itself. Maybe it's something that you're learning in strengths of materials where you do a tensile test. There's so many, many, many different tests, okay? So what tests do you need? There's actually two types of testing that we're going to look at: verification and validation. With verification, you're going to ask, did we make it correctly? So we're really looking at how do we map the design outputs that we have to our requirements or specifications. So here our specifications are really important, especially that they're measurable. Because if they're measurable, we can test something, measure it, and see how well that meets our specifications. So these are things like debugging, tensile tests. They could be something like just weighing it or measuring the size, okay? That's seeing if they meet the specifications. That's verification, meet the specification. The other type is validation. So did we make the right thing? So we talked about the design process. We have a lot of different stakeholders, right? They all have different needs. We need to make sure that we are meeting the needs that we set out to meet, all right? So this is doing things like user testing or simulating use or doing functional or performance tests. All right, so kind of a lot going on there. I broke it down into sort of asking questions. First of all, what are your specifications and your user needs? If you don't have those well defined, you can't test. So that is such a crucial part of our design process. All right, so you need to make sure those are detailed out and ready to go. And then you can start asking, how do we test if we meet each specification? All right, maybe your specification is you have a size constraint. It needs to fit in specific dimensions. Your test can just simply be that you measure your solution and make sure it fits. All right? Maybe it's mass, maybe it's durability, right? You can just weigh it. Do we meet what size the mass that we said we have to meet, right? Maybe somebody has to lift it and it can only be between 10 and 15 pounds, right? Just weigh it. Once you have all the specifications, then you can also think about, what do we need to test to see if we met the user's needs? How can we see if we met users' needs, right? We can simulate the use, so you can simulate what's going on, what your product is or your process is. You can also do functional tests, like just seeing if things work under normal operation. You can do customer testing and customer feedback, so give it to others. give it to your customers and see what they say. All right, so those are the two things, the verification and the validation, and it all comes back to making sure that we have specifications and user needs well defined. And if we can test them and see if we met them, we'll know if we created something that meets the problem we set out to address. When you're doing testing, it's best if you come up with specific protocols. So we're going to ask you to come up with testing protocols and then do the tests and present the results. And then based off of those results, you can either say whether you've met the criteria or not. And if you have not, that's good information for you to know that you need to go back and iterate and consider, can I improve my solution to meet those specifications? All right, and so what you do is you try to be really specific. So if you just want to see if something breaks when you bend it, because that's a bad thing, your design won't work if it breaks, instead of being very broad, try to get more specific, right? Try to talk about what you actually need to do that test and use numbers if possible. So first, install your handle fixture, then apply a specific amount of force at a specific spot and use this tool and then see what happens, right? That's a more specific test. What you'll do then is write a protocol to do this test to help you go from something like checking to see if it breaks when bent to this. What you want to do is write down what product you have, give the test a name, say whether it's the verification or validation. So is it a specification or a user need that you're looking to see that if you've met? Talk about who would do it, the test. Maybe you need some background material, maybe you don't. Maybe there's a formula you need or some reference material about where this test came from. What materials do you need to complete the test? How are you going to do it? What methods or procedure do you do? And then what is your acceptance criteria? All right, so that really comes back to those specifications and those user needs. Let's look at an example though, all right? So it's kind of abstract now. What if we designed an automatic can crusher? And these are our specifications. And we're going to look specifically at seeing if we can crush the cans like we expected. We want them to be 1/5 of the original volume. All right, so we need to come up with a test that sees if our design will meet this specification. All right, so how do we do that? We write a testing protocol. We give it the title of our product or project. We give the test a name, volume reduction. We are doing a verification because it's of our specification, not a user need. Who's going to do it? Our team's going to do it. Background. We're going to talk about volume here, so we've got a formula for volume. We have a can, it's a cylinder, so we'll use the cylinder formula for volume. And then we'll take our materials. We're going to take 10 cans, and we're going to get calipers and rulers so that we can measure things, measure our dimensions. And then we talk about how we're actually going to do it. So we're going to measure the dimensions of one can. We're going to assume it's a cylinder. Then we're going to crush all cans. And then we're going to measure the crushed can dimensions and apply an appropriate geometric shape formula for whatever volume it is. So if it's still a cylinder, we can approximate like a cylinder. We're going to make some sort of an assumptions as to the shape, measure those dimensions, and calculate the volume. And then we'll look to see if we've met our specification. So we have an acceptance criteria that the final volume has to be less than or equal to 1/5 of the original. So it's the original of one can times our 10 cans divided by 5. All right? So these don't have to be extremely complex or like tests that take hours upon hours to do or things like that, right? It really all depends on your criteria and how can you check to meet those criteria. So what specifications, what user needs, how can you see if they're met? That's all there is to it, all right? And if you follow this test protocol, it'll help you write a nice and specific testing protocol that you can actually do a test for. And then once you do the test, don't forget to include your results of the test, all right? And and some conclusions from it, all right? If you did a test and it failed, then maybe those conclusions led you to go back and iterate on things. Or if the test succeeded, then you've concluded that you have a successful design for that specification. As a summary, what you need to do then is have prints or schematics, all right? So provide drawings or 3D SolidWorks models of things. Have a manufacturing or production plan, and the things that you need for that are on that slide back there. Have a bill of materials. Those things are on that slide to see an example. We're going to cover manuals later, so you'll have to have a manual for your process or product device. And then also do testing. So you're all going to have probably 3, 4, 5 specifications. So you're going to have 3 or more tests that you're going to do. And then don't forget to actually get results and conclude something with those results. And we have a nice example of the automatic can crusher for you to model your own testing protocols after. Any questions on detailed design? It's a little ahead of the game, and I'm sure that you have questions. Warren? Oh, you're stretching. All right, if you don't have them now, you will, because all your projects are different, okay? They're all different, and I cannot stand up here and tell you exactly what each one of you needs without talking to you more specifically, all right? So if you do have questions, when they arise, let us know. All right, so if we're going to get to that end point, one thing we can do to get there is to prototype. We're really then going to be testing, seeing how our different solutions work out. We're going to have 3 different prototypes. So what is a proof of concept prototype? This is really just sort of an abstract prototype. All right, so you use materials that are completely readily available to you, either in the makerspace or just in your own home or out of the recycle bin. So cardboard, popsicle sticks, straws, these kinds of things. So it's pretty abstract, but you're going to look to see, like, you know, are things moving together? How do things fit together? What does the size look like? Relative size of different pieces, things like that. All right, so that's the proof of concept prototype, is really an abstract kind of thing to just get a general sense of what are you making? You know, how is it going to function? How is it going to work? That kind of a thing. What are the moving pieces that go into this? The next prototype, you can use materials readily available to you. We do have some scrap materials that are for your use in the makerspace, but you will also probably be ordering stuff at this point. So this is why we talked to you a little bit about the production and the bill of materials. You have a project budget for this, so as you do your bill of materials, as you order things, make sure you have a budget. So that should be in your Google Drive folder. Everybody should have a budget in there where you detail what you're buying, how much it costs, and as things go down, you'll see how much budget you have left. And that will help you make your bill of materials too at the end of the day. You'll see which one of those things that you bought did you actually use for your final prototype. And if you need to order stuff, these slides will be posted, so there'll be a link to our engineering website. Through the lab website, there's a spot where you can do material orders, so you order your stuff there. There's different ways that you can specify if you want any sort of wood products or fasteners or sheet metal or PVC pipe, or there's another section for others. So if you have other miscellaneous things that are not one of these more specific products, you can list those too. And then you'll also make a final product or design as your 3rd prototype. So this will be really dependent on what your first prototype looks like. There may be maybe some minor modifications, or maybe a major overhaul of your product or design. It really is just going to depend kind of what happens with your first prototype. But you have an overall project budget of $250. Some of you won't go anywhere near that. Others of you are going to be pushing that limit. And if there is a great need to go over that project budget limit, please talk to us professors early, and we'll see what your project entails, and you can make a case for possibly going over budget. All right? So generally speaking, though, project budget of $250 should be good for most people. Any questions about prototyping? The proof of concept prototype should be a fun activity, all right? You're just using tape, glue, things you randomly find to see what you're making. So I hope you have fun with that. I'd be excited about making that. It's kind of like crafting a little bit with a purpose. And we have a little bit of extra time today, so we're going to do some project work stuff.